Hello and welcome to a new video from Byte Analytics. In this video, I'm going to talk to you about the distinction between calculated columns and measures in Power BI. Now, I know what you're thinking. This is a common topic. It's one which has multiple resources already online, and everyone knows about the difference between calculated columns and measures, which is fine, absolutely fine. But stick with me. What we're going to do is walk through an example of when we use calculated columns and what types of problems we get and face, and then when we switch to measures, what type of problems we face there. Even though this is common knowledge amongst many of Power BI developers, in reality, the problems only come to life when we actually face a real life situation. So I'm going to walk you through that shortly, but before we do that, let's just recap on some of the key differences between calculated columns and measures in Power BI. So firstly, let's look at evaluation. When it comes to evaluation, calculated columns are evaluated at the point of refresh. That means when your data model is refreshed, that is the point at which the calculated column will refresh its metadata and present you with a new value. Now, to be strictly accurate with that, if you ever change a formula for the calculated column, that again will be a point in time when the calculated column will refresh its metadata. In contrast, we have measures which are evaluated at query time. So anytime a user looks at a visual which is reaching out to a column, that is when a dynamic measure is actually queried. Moving on to storage, calculated columns are persisted in the model, so they do add to your model size. So imagine having a table with 1 million rows of data and you add a calculated column to that table. You've just gone ahead and added another 1 million values to that table. So keep that in mind. Calculated columns are physically stored in the data model against your table and would add to your table size. Measures, in contrast, are never really stored. They are computed on demand. They are dynamic, and that's why they are so lightweight. So that is a big difference between the two. Let's move on to context. Calculated columns automatically have a row context. It's quite a simple concept, really. So if you have a column against a table, a physical column, naturally it will have a row context and it will iterate or move through as many rows as are available in that table. Measures, on the other side, don't have a row context, but they do operate in a filter context. So they respond to filters and slicers or actions by the user on the canvas, and the measure will respond accordingly. When it comes to use cases, the typical use case for calculated columns is categorization, lookups, static flags, and anytime you need to see a raw value on the canvas in Power BI, you generally want to use a calculated column. Measures, on the other hand, are generally suited to aggregations, KPIs, or dynamic totals, a total which is going to summarize a large volume of data and present you with a smaller value or a single value, and it's going to be dynamic, is best suited to a measure. Now that we've covered all the basics of calculated columns and measures, let's jump into a real-world example. And as I said before, it's not until we start developing the reports that we hit some of these problems, and that is when we uncover some other challenges between calculated columns and measures. Here we are inside of Power BI, and I'm looking at the notorious AdventureWorks database. So one of my report users and teams that I was working with wanted to classify their customer base in terms of low, medium, and high based on the sales amount. So any customer who was selling above a particular threshold would be classed as high, potentially, and within a given threshold, medium, and below a given threshold would be low. And I'm going to use the AdventureWorks database to try and create the same scenario, but whilst doing that, I will hopefully highlight some of the key findings and the experiences. Simply not just looking at a slide which tells you the difference between calculated columns and measures. I want to really paint the picture of the problems that you face in a Power BI project when you work between calculated columns and measures. So this is typically what my report users started off with. So this is what they did. I have here dim customer, and this table is representing one row per customer, and it's the dimension table for the customer records. And it makes perfect sense to start with, at least, to create a classification inside of dim customer so that they can be classed as either high, medium, or low when it comes to customer classification. So typically this is what my end user team did. So they came over into the table and they created a new column. So I'm going to do that here. And we have our new column code ready to be populated. So let's come in here. I already have my code copied and I'm going to paste that in here. And I'm going to call it customer segment column. And what I've got in here is a formula which goes and stores a value into a variable. The formula is summing up the sales amount in the related table, which is the fact internet sales table. Well, the sales amount sits inside fact internet sales, and therefore we're using the related table function. That function is going to reach out to fact internet sales, sum up the sales amount, and bring it back into the sales amount variable. Perfect. Let's move on. Next, we have some logic, and we're simply handling some blank values here. We're not interested in the blanks, but what we're saying is if the sales amount is less than 1,000, then classify that customer as being low. If the sales amount is less than 5,000, then classify that customer as being medium. Otherwise, everything else, i.e. everything above 5,000, should be classed as high. Nice and simple formula, so let's do OK to that. And you can see now in the background, if we go all the way to the end of the table, we now have a column, a physical column stored in dim customer, which is the customer segment column. And as we expect, it has values of high, low, and medium, just like we wanted to assign our customers. However, there is a problem with this, and the next bit we're going to work on is going to highlight that problem. So let's go over to the canvas view, and now if I was to pick some records from this table, so let me pick out the customer key firstly. That's the unique key for each customer. I'm also going to pick out the sales amount, for which I already have a measure. And now I'm going to pick out the segment column, which I've just created, and it's just here in dim customer. Here we are, so I can see that there. Now, whilst that might look okay at a glance to begin with, let me just make that a little bit bigger for you. There's actually a problem, and the problem is these values cannot be trusted. We're still to test whether this is responsive to any slicers or filters. In the real world, on the canvas, it's very unlikely to have simply a table of values. So it's always good practice to test your results. In my case, what I want to do, I want to introduce some slicers on the canvas, and I'm going to place calendar year on the canvas as a slicer. And what I want to do, let's just change this over to a drop down. In fact, let's do vertical list, make it easier. And now, even though we can see a customer segment column, it's going to become evident as I move through the slicers that this is actually incorrect. So I know the data starts in 2011. There's nothing for previous years available in the model. So let's go over to 2011. And I can see the first customer key 11,000, has a sales amount of 3399. But the classification, the segment column, is stating it's high. Now that is actually incorrect, because if we go back and look at the segment column, the formula is stating that anything less than 1,000 should be low, anything less than 5,000 should be medium, and anything therefore above 5,000 should be a high. So this formula is currently incorrect because the value is less than 5,000. But why is it giving me a high? And the reason for that is because the column, the calculated column, is not sensitive to the filter context which is being introduced here through the calendar year slicer. Let's carry on and test it for another year. Again, we can see customer key 11241, they have a value of 2049 and 10 pence. And again, the customer segment column is high. So clearly this solution is not working. And just to iterate that again, it's because the calculated column is not dynamic. The value inside the calculated column, i.e. inside this table, is stored based on the full total which is being returned in the formula. So this column is not dynamic in any way, and it's not going to serve our purpose. So now the next step is, how do we rectify that? Well, we need to create a measure. Rather than a calculated column, we're now going to create a measure and then place that next to our calculated column, and we're going to see if that actually makes a difference. So let's make some space here. And now let's go ahead and create our new measure. Once again, I have the code for the measure pre-copied, so I'm going to paste that in here. And you can see it's exactly identical to what we had in the column. What we're saying is we're putting the sales amount. This time we're going to reference a measure. We're referencing the sales amount and placing that value inside a variable. We're then handling the blanks, but the logic is the same. We're saying if the sales amount is less than 1,000, then that should be classified as low. Less than 5,000 should be classified as medium, and anything else, i.e. above 5,000, would be classified as high. So that looks good. Let's add that in. And now what we're going to do is place that measure onto the canvas right next to the column. So let's just rename that to measure so you can see the difference. And now let's place that in the table. And now what you can see is this particular customer here who had a value of 2049 and was initially classed as being high in the calculated column. Using the measure, this customer is being classed as a medium. So let's go over and validate that. If we look at the measure formula, anything less than 5,000 should be classed as a medium, and that threshold goes from 1,000 all the way to 5,000. So that formula looks correct there to me. And let's jump over to 2011 once again. And here again we can see customer 11,000, who was previously classed as being high based on the total sales, is now being classed as medium as well. So once again, if I look at the definition of the measure, I can see anything less than 5,000 and between this threshold here should be a medium. So now that is the correct way to achieve a dynamic response. And the reason for that is the measure is sensitive to the slices which are being placed on the page. So with that, I was able to resolve this for the reporting team in the project that we were working on. And this is a classic example of when a measure is a better choice than a calculated column. But that wasn't the end of it. We actually had to move on and create a visual. So the next question from the team was that I want to create a visual which shows me low, medium, and high, and I want to place the customer counts within that visual. So how do we achieve that? So the next step was then to place a clustered column chart on the page. Let's bring that over here. Let's make some space here. And what we want to do is actually bring the axes for low, medium, and high onto this visual. And how do we actually do that? So I've created this measure here, but the problem with this measure is that I can't actually add it to the axes of this visual. So this is another distinction between calculated columns and measures. You cannot place a measure on the axes of a visual. So that was the next problem we faced. Essentially, the customer said, well, I want to show low, medium, and high, but I can't do it. So how do I do that? Clearly, it's not going to work through a measure, and clearly we can't use the calculated column which was created previously because that was the wrong result. It's based on the full sales amount. It's stored in the column as of that point in time, and it's inaccurate. So how do we actually resolve that? So since we can't rely on a measure for creating a axis on a visual, one of the other ways to resolve this challenge is to create what's called a disconnected table. So now we've gone from understanding some of the drawbacks of a calculated column to resolving that with a measure, but now we're also looking at one of the drawbacks of a measure, and now we're going to resolve that with a disconnected table. So I already have a table here called segment, and if I look for segment table, it's quite simple. I've created a data table using low, medium, and high, and this table is going to allow me to place the segment on the visual so that I can actually create the axes for low, medium, and high. So let's do that. Let's drag that onto the visual, and there's nothing there at the moment, but I need to now create a measure, a dynamic measure, which is going to count the customers and allocate them to the classification of low, medium, and high based on the slices and based on the sales amount. So let's do that next. So let's go over here and create a new measure. And once again, I have the measure code pre-copied. So let me paste that in here. And actually what this needs to be is the measure name. So it's customer segment measure. Let's correct this here. Okay, so what we're doing, let's understand what the measure is trying to do here. We are looking at each value in the segment table, i.e. the low, medium, and high, and we are placing that inside of a variable. So the selected value goes and looks at each value one after the other, almost like an iterator. It's not quite an iterator, but it looks at each value and places it inside a variable. We are then counting the rows of a filtered table, and the filtered table is based on the values of the customer key. Now, values gives us a unique list of values to pick from. In our case, the customer key is unique anyway because the grain of dim customer, the customer table, is one row per customer, but it's good practice to use values anyway. And what we're saying is for each one of these values, we want to calculate the count rows, apply the count rows to the customer segment measure. And we're counting, literally, we are counting each one of these values here that you see in the table. So let me just spread that out. So what we're essentially doing for each one of the values stored in the variable, i.e. low, medium, and high, we are counting all the matching values inside of the customer segment measure, i.e. those are the values in this column here. So whenever there's a low, and that's going to get counted and it's going to get assigned to the axes in the visual, which is low, the same for medium and the same for high. So let's try and placing this measure on the visual. And now we can see we actually have a count of customers for low and medium. And that's because I'm currently filtered to 2011. If I take that off, I should see low, medium, and high, and that's fine. So this is how we can actually assign values to a classification which doesn't necessarily sit inside of any one of your dimension tables. So we've created a disconnected table and we're now counting the values and assigning them to be able to create our visual. Now that we've got this far, how do we actually test that our visual is returning the correct results? Well, there's a couple of ways we can do that. So what I want to do firstly is I've created a customer count measure. and it's simply a distinct count of the customer key. So what I'm going to do, I'm going to place this customer count into this table. Let's stretch that out a little bit. And you can see we have a total of 18,484 unique customers, and that's fine. And let's now take away this first customer segment column because that's incorrect. All we want to do is validate whether our newly created measure is matching up to the visual here, which is dynamic, of course. So what I'm going to do is filter this table down to a particular value, and then I should be able to see if the value for a given classification matches the values which are coming up in this visual. So first thing, let me place a filter on this visual here. So that is the measure, and I'm going to say I want to look for anything which is low, the low classification. Okay, so we have 10,788, and let's filter that down to a particular year. We have 253. So let's now hover over this value here, and there you go. I can see this column chart here is showing me 253 matching values. And let's do the same for medium. So if I go over to the filter on this table, and let's filter for medium. This time we have 1,886 unique customers which fall under the medium classification. So let's hover over our visual here, and you can see 1886 is correctly matching up to this total here. And that is on a filtered context. So if I was to remove this, in totality, we should also see same numbers. So I hope that was useful for you. In this video, what we've looked at is reminded ourselves of the key difference between columns and measures. We then went on to look at how a particular calculated column might seem to be the optimum solution, but in reality, it doesn't quite work for the given requirement of our report. We then looked at how we can overcome that limitation by the use of a measure. We then looked at what problems the measure creates for us, i.e. we're not able to use a measure on an axis. And then we looked at how we can resolve that problem with a disconnected table. And really, we've done an end-to-end full circle of some of the real-time problems that we get on projects, not just looking at what the difference between a calculated column and a measure is, but really getting behind what actually happens on projects in reality as we work with our users. I hope that was useful for you. Thank you for watching.